All right, good morning. Today we're going to take a look at calculating energy and wavelength. So in this one, they're asking us to calculate the energy and wavelength of a photon of light with a frequency of 6.165 times 10 to the 14th hertz. So on this one, we'll be using some of Planck's constant, and we'll also be using the speed of light. So we're going to start with the energy part of this first. So I know we have some given information, and we have some unknown information. So the given information that they gave us is they gave us frequency. And they want us to find energy. Okay, so we know we have an equation for energy. So if we go back to the classwork, so this will be in Schoology as well. So we have some equations here. So we'll be using the energy is equal to Planck's constant times its frequency. All right, so another given that we have Planck's constant also. So if we look on here, we have all of our constants. So we have Planck's constants, we have the speed of light, and we also have conversion. We also have the conversion for nanometers to meters. We had a little technical difficulty there. All right, and we're back. So my Planck's constant is going to be so it's going to be 6.63 times 10 to the negative 34 joules times second. So now I have my variables for my equation. Now I just plug it in and multiply. So I'm plugging in H first. And then we're going to have that multiplied by the V part. So V is going to be 6.165. All right, so we've got most of our stuff here, and so what I want to do is let's change this. So of course I know Mr. Cantor is going to look for my units first, so I'm going to do the units first. And if I have the units, there's a possibility that I'm going to get the correct answer. If the units are not correct, then I know that I'm probably not going to get the correct answer. So this will be joules times second. Now I know hertz, that's equal to 1 over second. So I can replace that 1 over second. Then we just get joules second over second, and that's just going to be equal to joules. Now I want to check and make sure, is this a unit of my unknown? They're asking me to find energy. So yes, this is a unit of energy. So I'm going to write that down over here. That's joules. And then the next thing I want to do is I'm looking at my exponents. So these are something that I can easily knock out. So I have exponents here. So I'm just going to use a little bit of algebra. So I have some algebraic properties. So I know we have 10 to the A times 10 to the B. That's just equal to 10 to the A plus B. So I can just add exponents with a like base. Also, we have a like base, and we're dividing, we can subtract exponents. So that kind of simplifies my math and what I have to put in the calculator. All right, so I'm looking at these. So this will be negative 34 plus 14. So that'll be times 10 to the 20th. And then this part we can just plug and chug, but I know it's going to be around 1. We have 6 divided by 6. Oh, no, I'm sorry. This is multiplied. So that's going to be about 17 something. Actually, we've already done this one, so it's 17.77. That's not correct. That's a different problem. So we have 6.63 times 6.165. We get 40 joules. And then we want to write in scientific notation. And so now we've calculated for energy. They also want us to find the wavelength. So that's easy as well. So we just start off with the new given. We'll start off with the new unknown. We'll go from there. All right, so here we have some given information. You know, a wavelength, that's going to be 6.165 to the 14th. We have unknown. They want us to find the wavelength. And then for wavelength, we're going to be looking at this equation. So wavelength is equal to C over V. So we have wavelength is equal to C over V. So C is a constant. That's going to be my speed of light. So speed of light is going to be here over in the side, 3.0 times 10 to the 8th meters per second. All right, and now I have my variables. Now I'll just plug in my equation. So I have C and we also have frequency, hertz. So of course, I'm going to look at the units first. And then if the units check out, I'll keep going. But if I don't get the correct units, then I know I need to do some more work. So I'm going to go ahead and change that hertz into 1/2. And then I'll use a little bit more algebra. So when I have fractions inside of a fraction, I know that we have A over B over C. I can just drop that down. This would be A over BC. And then I also have the fraction on the bottom. I can just flip that up. That would be AC over B. So here I'll shift down and then I'll flip up. So we'll get meters per second. Second on top, they'll cancel. I'm left with meters. So I know meters is a unit of wavelength, so I'm good on that. And then I'll subtract the exponents, 8 minus 14. And then we'll divide here and we'll get 0.49. And that'll be my wavelength lambda. So just some points. C is a constant. That's going to be my speed of light. And then H is Planck's constant. We have the equations that we'll use. Make sure we're using our algebra, fraction over a fraction. We can shift down. fraction and the bottom of a fraction we can flip up. Hertz is 1/2. And make sure you're checking your units. I always check the units first, and then that kind of gives me a guide to the correct answer.